Hi, good morning. This is Prem Kumar, Assistant Professor, Department of Computer Science. Today we're going to discuss about the subject Computer Architecture and Organization. In that, we're going to discuss about the 8085 instruction sets. This is a very interesting topic. We'll see, look into that. So, we'll perform the operations. That is, to perform on any operations, we have to give the corresponding instructions to the microprocessor. That is, each instruction the programmer has to specify three things. One is the operations to be performed, the address of the source code of the data, and the address of the destination of your results. We'll see that. So 8085, an instruction is in a command or a pattern given designed inside a microprocessor to perform a specific functions on given data. The entire group of instructions that a microprocessor supports is called the instruction sets. The 8085 has 246 instructions. That is 246 instructions we have. Each instruction is represented by an any 8-bit binary values. These 8 bits of the binary values are called the operation code. In short, we call it as an opcode. That is called an operation code or the instruction bytes. So this is a general diagram about the 8085 instruction sets. It is been classified into a three term. That is the based on the operations, based on the arithmetic mode, addressing modes, and based on the length of your port size. In the case of the base of operations, so you have data transfer instructions, arithmetic instruction, logical instruction, branch control, stack, input output, and the machine controls. In the case of the addressing modes, direct addressing mode, register addressing mode, register indirect, immediate, and implicit are implied. In the case of word length is the 1 byte, 2 byte, and 3 bytes. We'll see further in detail about the instruction sets there. In the case of data transfer instruction, an instruction that is used to transfer the data from one register to another register is known as the data transfer instruction. So the data transfer can be done from source to destination without changing the source content. The data transfer mainly transfer from one register to another register, from memory locations to registers, or register to memory, and between the input devices and the accumulators. Example of data transfer instructions are we'll be seeing some example that is move r comma m. That is, this data transfer instruction is used to transfer data present within the memory m to the register r. But the memory location address must be there within the HL register pair. Then the next one is that given example that is move r comma 1020. Here r refers as a register and 1020h is nothing but your memory location. In the case of arithmetic instructions, the arithmetic instruction performs different operations like addition, subtraction, increment, decrement, and the data within the memory and register in 8085 microprocessor. For example, so we have an arithmetic instruction that is add m, which means it is going to add the memory, it is going to add the content which is in the memory location and with an accumulator data, the result is also be stored only in an accumulator. So in the case of any arithmetic and logical operation, in the case of microprocessor, one data should be in the accumulator and another data should be either in the memory or any other registers. At last, after performing the arithmetic instruction, the result will store only in an accumulator. So given example that is add 28h, that is 28 is a data, immediate data. So it is going to be add with the accumulator content. So we have some other data that is the second number should be in an accumulator. So by adding the accumulator content with the 28h, the result is also being updated only in an accumulator. The case of logical instruction, the logical instructions are mainly used to perform different operations like logical and boolean over the data available in either memories or registers. These instructions will modify the flag bits based on the operation executed. Examples of logical instruction, the ANI that is and immediate with accumulator. So the data which is in the accumulator it is going to be and logically and immediately with the data which you given it in the instructions. This instruction executes AND operation for the immediate 8-bit data provided as an operand by the data available in the accumulator. The example that is ANI 35H. So the 35 is going to be AND with an accumulator content and the result is also be updated only in an accumulator. In the case of branching instruction, These types of instructions are mainly used to transfer or switch the microprocessor from one location to another location. So it simply changes the general sequential flow. The example of the logical instruction is the jump. So it is an unconditional jump. So we call it as an unconditional without any condition. Whatever the address which we are specifying in the instruction to that location, it is going to be the control has been transferred. So this is what the use of the JMP address. This type of instruction is mainly used to transfer the series of the current program to that location of the memory whose 16-bit address can be simply specified within the operand of the instructions. That is, the example is JMP 2014. So 2014 is an address. So now the currently bit of whatever the address it was in an execution, it will be shifted over to the location 2014. That is the use of the branching instruction. In the case of control instruction, these instructions are mainly used to control the microprocessor operations. These instructions are discussed below, that is NOP. NOP is a term, it is used for no operations. The no operation stands for NOP. And once the 8085 gets these instructions, then do not perform any operations based on the execution. So it will never perform any other instructions even after executes the NOP. Then the direct addressing modes, which was in this, the address of an operand is given in the instruction itself, that is LDA 2500. So we'll be load the content of the memory location 2500H in accumulator. So LDA is an operation, 2500H is an address of the source, and accumulator is the destination. In the case of register addressing mode, the data is copied from one register to another register, that is move A, M, move the content of a register B to the A. So it will be transferred from the right to left. So in the case of any transfer instruction load, move instruction, the right side, whatever the operand we have, that operand data is going to be copied to the next, that is, the instruction is going to be from right to left. So B will be the rightmost element, that is a register. That register content is going to be moved to the previously whatever the register we have, that is an accumulator. So where it is going to move the data from B to A. The move is an operation, and B is a source of data, and A is the destination. In the case of register indirect addressing mode, the data transfer from one register to another by using the address pointed by the registers. The move IM. This is what an instruction. Move the data from the memory location specified by the HL pair to the accumulator. Then move is an operation. M is in a memory location specified by the HL register pair, and A is the destination. In the case of immediate addressing mode, in this mode, the 8-bit or the 16-bit data is specified in the instruction itself, and one of its operands, that is MVIA 05, that is, so we're going to move the immediate data 05 to the accumulator. So the MVI is nothing but move immediate, and A is the destination where it is going to accept the data or it is going to receive the data 05. So the MVI is an operation, 05 is the immediate data, that is the source, and A is the destination. In the case of implicit or implied addressing mode, this mode doesn't require any operations. The data is specified by the opcode itself. The CMA is an example for this implicit or implied addressing mode. That is, CMA is a complement with the accumulator. The CMA is an operation finds and stores the one's complement of the content of an accumulator's A in A. A is a source and A is the destination. It takes the data from the accumulator, and after performing all the operation, the result is also going to be updated only in the accumulator. That is what we say here. A is in a source and A is in a destination. So hope you all enjoy the session. Thank you.